San Antonio at APEC 2026. We're here at the Renesas booth with Antonio Pietro Scalia. I'm sorry, that was the
It's
last
okay,
time.
that was San Antonio.
But
Yes.
anyway, we're here at the Renesas booth. They have a lot of things, but today we're going to take a look at a rather unique application of their GaN that sort of demonstrates a number of different things.
It is a 500 watt microinverter implemented with the single stage topology thanks to the implementation of the bidirectional GaN 650. We launched this product at APEC this week and we are enriching this portfolio. This part is 110 million, perfectly suited for this. Great behavior of RDS on with temperature, so the temperature does not increase the RDS on significantly, about 1.5 times, and then it's a very reliable solution because a fully isolated gate in the structure. We operate at about it's in a fully resonant LLC configuration with bidirectional GaN, and we switch at about 1 megahertz. We have digital control for implementing all the protections, and as you can see, the board is very limited and can be used in microinverters in a market standard.
You mentioned that this is the same form factor as the Enphase.
Yes, correct. If you look at the encapsulation of Enphase, this fits pretty well into their microinverters that you see on the roof of the houses, right? Taking the DC and then going into the grid.
And you say this is bidirectional, so
correct. So basically here you implement the theoretical operation in the first and the third quadrant, right?
Right.
And in our technology, actually, the reverse voltage, where basically no device is conducting, it's just one voltage drop because we have the cascade configuration that enables that with the silicon MOSFET.
And you say you do this in a single stage.
It's a monolithic device with two small 30-volt silicon devices put on top. The topology is single stage that we can see here. Yeah, exactly. So here typically you have a dual stage, right? An AC-DC followed by DC-DC. But here instead, specifically you can see the micro inverter. Okay, in this you see very well the single stage conversion embeds the DC-AC and AC-AC into the single stage. This is made possible by the bidirectional device. This is the topologies that sees on the first, on the primary side the 100 volt MOSFET, and on the secondary side the half bridge configuration of the BDS driven by digital controller. Here you see the board, main characteristics, switching frequency in a range from 200 to 800, right? Supplied by digital controller. And then in the next slide, probably exactly, you see the operation of the bridge, specifically that allows you to generate the output.
So this allows
sinusoidal.
for a more compact, more efficient, and you said implementing in SiC would take twice the number of.
Absolutely. If you try to implement an OBC topology, now reverting the inverter into an AC to DC, you can save as well a lot of components, because instead of using 2 times 750 SiC, you can use one monolithic device, 750, with basically half of the RDS on, double of the RDS on, and saving basically 4 times the cost of silicon carbide solution.
Pietro Scalia at Renesas. I want to thank you for your time.
Thank you, Lee. Pleasure to talk to you today.